A very good afternoon to all the esteemed panelists, respectable academicians, participants from the varied industrial segment, and our dear student. I feel privileged to extend a warm welcome for today's expert for workshop on exploratory factor analysis at MIT University Online. Conducted by the global facilitator, MIT University Online act as a catalyst to bridge the gap between theoretical and practical aspect of the professionals. The objective of this workshop is, of course, to help the participants to understand the essentials to develop a research project or paper, to inform them in creating an understanding of handling data. The workshop will provide conceptuals to know about the application-oriented knowledge of factor analysis. Today, we have with us eminent faculty from MIT University Online, Dr. Sunil Kumar and Dr. Monica Rose. The workshop is being conducted in two parts. First half will be covered by Dr. Sunil Kumar, where he will be talking about how to deal with the data in order to conduct effective factor analysis. And in the second half of the program, Dr. Monica Rose will conduct the factor analysis on SPSS. While we are holding the session, I am just requesting my audience, and I would like to request everyone to place all their queries in the chat box, which will be responded to by our expert speaker at the end of the session, through the session and answer approaches. So whatever comes to your mind, any query, any question, please do write, do mention the same in the chat box. So now let me introduce Dr. Sunil Kumar. Dr. Sunil Kumar is working as an assistant professor in MIT University Online, Noida campus. He is a PhD in management, MBA in operations, BE in food technology, and diploma in food technology. He has over 9 years of rich experience into education, including industry experience. He has published one innovation patent at IP Australia, presented various research papers on different national and international conferences and seminars, and published research paper into different journals of repute. His interest area is into business statistics, research methods, operations, and supply chain management. So now I welcome Dr. Sunil on panel. Welcome, sir.
Thank you, Vandana, for giving such a nice introduction. So we will begin on, just give me a few seconds. I will share my screen.
Sure, sir, sure.
Is the screen is visible?
It's quite clear, sir. Go ahead.
Thank you so much. Thank you, Vandana, for the confirmation. And I would like to welcome all the participants on the workshop on exploratory factor analysis. So the factor analysis, what we use for various audience, whether the audience working on the PhD thesis, whether we are working on the research work, whether research paper, whether we are working on the final year project work. So every dimension, we are more focused, we are looking into some or other way or some or other kind of research work, depending upon which area we are dealing with, right? So we need to look forward to what are the aspects we are looking forward to and why we are conducting these research. What is the objective? What is the purpose of conducting these research on the different levels? What outcome we are looking for? So we are trying to look to establish some facts. We're trying to establish new conclusions. We're trying to understand a new dimension, new horizon, which we can explore for our study purpose, right? So that is the whole sole purpose of conducting the research for the study purpose. Now, when we are doing this research, it can be of your qualitative nature or it can be of your quantitative nature, where either it is a qualitative in nature or the qualitative aspects are being involved or the quantitative aspects are being involved. We follow some generic steps, right? So these generic steps which we follow for conducting any research process, and these research process, these research activities which starts starts with identifying the research problem, right? Where we try to address some issues, where we try to explore some opportunities, correct? This is what we are looking for while conducting any particular research work. Now, when we are trying to explore some ideas, some new facts, some establishing some new figures, in that process, the first we talk about the introduction where we are describing about our a problem, our issues, our possible opportunities. Now, then what we do, we move to the literature review. What we do are doing in the literature review, we try to look for the available resource, available data which is already present, already information which is already present. And then we move to the research methodologies, then data analysis, finding a conclusion, suggestion implication, bibliography reference. But what is the most important point what we are going to discuss today is about data analysis. So when we talk about the data analysis, so data is a term where it's itself represents large information. It conveys large message. And how we interpret, how we utilize these data for the calculation, for analysis purpose, that conveys a different meaning. And that make it very important for us to manage these data, which is very large in size. And because practically, when we do any kind of research, we don't get the data for like 10 data, 10 set of information, or 15 set of information. No. What happens? We usually have 500, we have 1000, we have a 10,000 information with us. So when we have those such a large data with us, which need to be managed. So how we are going to manage those data? Because these data, when if it has been managed properly at the initial, at the very beginning, then it won't create any problem or any confusion or any difficulty at a next level. So how we are going to manage these data? And what are the key areas in which these data are being managed? So can you think of those critical areas, a critical point in which we can manage these data? What is the first thing which we feel that it is the most problematic while managing the data, while managing the use set of information which is available with us? The first and the foremost thing which comes into the picture is the missing value, right? Then is outliers. How we manage our linearity, normality, and multicollinearity, where these are our basic assumptions of the requirement of any multivariate analysis. Now the question is, what is missing number? And how we are going to deal with those missing numbers? And what could be the probable reason why these missing numbers are there in our data set? So how we are going to handle them? So these missing numbers can be arised because of the manual data entry procedure which has been taken care, or maybe the equipment error which is there, or because of the incorrect measurement. At times it also happens because some respondent doesn't give response to a specific question. I'm sure this must have happened with you while collecting the data for your PhD work, for your research paper. And the question said, many of the respondents or some of the respondent might not be comfortable for answering some specific question. Let's say some people are not comfortable for answering for their income, or maybe for their age, or similar some other variable, right? It happens. So how we are going to deal with it, and what problem it creates with us in the data set? So first and the foremost, it leads to the loss of efficiency and complication in handling and analyzing the data. Third, bias result from the difference between the missing and the complete data set. Now, when the data value is missing, it makes a direct impact on our descriptive values like mean, like standard deviation, other variance, because depending upon how many values are missing, because when we calculate the mean, when we calculate the standard deviation, we include all these individual data, all these individual values which has been involved. So that may impact on the normality, because when means is moving, has been making it skewed, then it will impact whole normality of the data. So it is very important to identify these missing number, to handle these missing number and rectify them. So how we are going to handle them? So there's various way in which we can handle these missing data. The first and the foremost is reduce the data set. That means eliminate those response where the data is missing. The second is treating them as a special value. Give it a special treatment, make them feel special. Then replace the missing value with the mean of whole data set, or we can replace with the mean of the given class, that class interval which it belongs to. Or we can do with replacing these mean values with the most common attribute value. That means for a question which may be similar, I'm sure you have prepared a questionnaire where you ask some similar questions to check whether the respondents are really willing to give the response to the questions. So that is where these similar questions also help us to eliminate the missing data and then the closest fit. Now, how to do this on SPSS or how to do this, we'll see in upcoming few minutes. The second major factor which influences whole data set is the outlier. So what is outlier? Why it gets so much importance? Why we are dealing with the outliers in the data mining, where we're dealing with the data cleaning? Why it is important? Now, when we say outlier, that means something which is going out of the box, or we can say it is going out of the way, taking a different way altogether in the data set. So what these outliers are? So these are basically those observation which lies an abnormal distance from the other values in a random sample from a population. So what could be the probable reason for getting these outliers? So it can be arised because of the error in the data collection, recording, or maybe during the entry, we make a wrong entry while putting from a hard copy of a questionnaire to the Excel file. Now, if you can look into the screen, the two different chart. One is scatter plot. So if you can see, the majority of the data are closer. They are intact to each other, right? They're closer. They're associated. They're working for a common objective, a common goal kind, wherein there are three values which is moving away from the general data set. So these three values are considered as outliers. Similarly, if you can see the box plot, the majority of the data which is lying between 70 to 90, but there's one value which is there 30 on the lower side. Now, since this value is very low, so it is making a direct, again, making a direct impact on the skewness, make direct impact on the mean value, making a direct impact on the standard deviation. And that is why it makes it very, very important to eliminate these outliers and make our data clean from the missing number, from the outlier. So once we address these two major phenomena, which is in the data cleaning, how we deal with these outliers, how we change, how we modify these values. The first way to deal with these outliers is the removal. So if this is a small example, if you have a small set of data where 100 is the one value which is out of the majority of the similar values, so we will eliminate these maximum value and then we can use the remaining data set. That is one way. Second, converting them into the log, and then we can utilize the value accordingly, whichever fits in, that value can be considered in place of the outlier. The third is the truncation. That means making this the highest value, which is an outlier, close to the highest value of the group of data set, which is together. So that is truncation. That value can be used. Then is robust method. That means trimmed mean. So what we are going to do in the trimmed mean? What is the meaning of trimmed? What is the meaning? So in general, if we calculate the mean of whole data set, let's say this is my data set, 1, 6, 12, 14, 20, 24, 36, and 100. So regular mean is 26.62. But trimmed mean says eliminate the 10 to 25% of data from the both the end, from the higher end as well as from the lower end also. And then they take the mean of the remaining values as the alternative for the outlier. So that is the and the technique in which we can replace the outlier. Then is vensorized mean. So what we do is there's two values you can see here. One is the smallest value, 100 is the highest value. So one will be replaced by the next value which is there in the common group, which is clubbing together, and the highest value will be clubbed, will be replaced by the next highest value which is there in the group segment, and then their mean will be taken, and that mean will replace the value of the outlier. So that is the another way of dealing with the outlier. And then the last way is a least median of a square. That means replacing this outlier with the median value, because we know median is not being affected by the any specific outlier, because it is more of a positional average, right? So just taking into consideration, we use that median to replace this particular outlier. So that is the another way of dealing with the outlier and replacing, because that is the general question which comes in our mind, that how we replace our missing value, which value we should consider, what kind of outlier is there, and how we replace that outlier, what criteria we should use. So these are the ways, or these are the criteria which we can use. These are the techniques through which we can replace our outlier in our data set. Because in every data set, there might be possibility of no outlier, then it is very good. If there's some outlier, then we can use any of them. The next important criteria is normality and linearity, where this normality and linearity in the data makes our model fit. And these normality and linearity are the primary assumptions of any multivariate analysis. So how we are going to measure these normality? How we can consider what is the criteria? What is the criteria through which we can say the data is normal, the data is linear? What is that? Those a factor which we consider. So normality we can check by observing normal PP plot and standardized residual histogram, where what we observe, this is the graph, this is chart where we try to see what is the symmetry of the curve, what is the residual value. So whether my curve is showing a bell shape, showing some symmetry. I'm sure you must have be aware of the probability distribution or probability density curves. So if my distribution, if my curve is bell shaped, is normal, right? That means there's symmetry in the distribution of data across the mean value, and there's a symmetry in the distribution across with respect to the standard deviation. So if you can see the curves which is there on the screen, the first histogram curve, where we can identify a bell-shaped curve, right? Where the majority of data are confined toward the central position, and a symmetrical distribution, a symmetrical variance, which has been observed across the central position, across the mean point. So for any normal curve, we know that mean, median, mode, all three lies in the same position, and a symmetrical standard deviation which has been observed. Now, when we look into this probability density chart, from the central, the mean value, if we look into 1 plus minus standard deviation, so 68.27% of data which is lying in that particular range, wherein if you look into the mean plus 2 standard deviation, so approximately 95.45% of data which is there. Now, if we move to the mean plus 3 standard deviation, approximately 99.73% of data which is there. So if the distribution has spread in that specific some pattern, then it is considered as a normal. Now, as I already quoted, if there's a missing value, if there's an outlier, that is going to affect the symmetry of data. Because if there is some very small or very large values there, if there's a very large value, it will shift the mean position, right? If you can see the curve, it will shift the mean position. So the moment the mean position is being shifted from the median and the mode, there's some skewness which has been observed. So there's an asymmetry in the data, wherein it is considered as positively skewed. But if there's an outlier which is on the lower side, then again there's shift on the towards the origin. Again, there's a long elongated tail. Again, there's a skewness which has been observed, which is again is a situation of asymmetry, and that represents asymmetric data, which is not normal in nature. So for a normal situation, we need to have mean median mode in place with a specific variance in it. Apart from the skewness, we can also check the symmetry, that is the normality, with the help of kurtosis. Now, if it kurtosis more focus on the peak, what kind of peak has been observed in the curve, right? What kind of peak? Is that majority of data are being synced closer to the central value, then what happens? It will create an elongated peak. It will create an elongated peak where this leads to the lesser deviation in the data, which is again not normal, and that is considered as a leptocurtic, wherein in a normal situation it is considered a mesocurtic. But what if the spread is high? Again, why there's a spread is high? Could be because of some outliers, could be because of the nature of the data which has been collected, and then again that situation is not normal. So depending upon what kind of the movement our curve shows, that is with the help of skewness, or what kind of the peak which has been observed in terms of kurtosis, so that is how we can also make a comment about the normality of our data, right? So when we looked into the normality, another important criteria is the linearity. So how our data is being spread. So again, the concept of standard deviation brings in, and the regression. So how our data has been spread. So if my majority of data are closer to my trend line, right, and it is showing some straight representation, then we can say that our data is linear. So what is the gap between the actual value and the projected value? So that error term again, which help us to identify and determine the linearity. What is the behavior of these data? So these are normality and linearity being the basic criteria, a basic assumption for my multivariate analysis. The next important assumption is multicollinearity. What multicollinearity talks about? Why multicollinearity is being given so much of importance, and why it need to be important to be identified. So when we talk about multicollinearity, we try to see what kind of correlation the two independent variables have. So how they are closely related to each other, how close impact they are making on the dependent variable. So that kind of effect, that kind of understanding we make to the multicollinearity. The question is how we measure, how we check these multicollinearity, how we are going to identify whether my data is showing multicollinearity. So there's various ways. Majorly, there's 4 tests which we can do. The first and the foremost is the correlation analysis, where we see what is the coefficient of correlation between the two variables. Second is the value of tolerance. If the value of tolerance is less than 0.1, then we can say there is the presence of multicollinearity. The third way is variance inflation factor, VIF, which should be greater than 10. And then a condition index. So if the value is less than 15, then the collinearity is suspected. But if the value is less than 30, then a serious multicollinearity. Now, let's quickly see the measurement scale, because we're talking about a factor analysis, we are talking about SPSS, and we need to define what kind of scale we have used for the data, on what is the nature of the data which has been collected. So that need to be specifically defined in the SPSS. So what are the major scales which has been used? I'm sure you must be knowing this. The major scales: nominal, ordinal, interval, and ratio. So nominal, something which we assign for identification, right? For recognition sake, right? But it doesn't follow any specific order. For example, race, gender, or religion, occupation, or the jersey number, or anything else like that, which is used for just for identification. Then is ordinal. So we follow a specific rank order, a income bracket. So when we give a, like in our data set, we say the first A1, which belongs to the group 10,000, 20,000. Second group belongs to 20 to 30,000. Third belongs to 30 to 40,000. So when we assign them a number, a specific number like A, B, C, D, or we can say 1, 2, 3. So they are in some hierarchy, and also they are used for some identification. So such scales are considered as ordinal scale, where the third scale which has been defined on SPSS is interval and the ratio. They're clubbed together. Now, specifically, the intervals are those where we, let's say, we measure attitude. How we measure attitude? Do we call, or do we say that there's a total absence of the attitude? When we say the person has zero attitude, is it possible? No, because there's some presence of attitude. When we say temperature, 0 degrees Celsius, still zero signifies something. So that is the interval. So it's like a scale what we use, like strongly agree, or to agree, then neither agree nor disagree, or disagree and then strongly disagree. So that is again a scale which has been used. That is the interval, wherein the ratios are those parameters where we measure the absolute values, right? For like height, income, month, consumption. So where zero signifies its actual understanding, actual meaning, and that is how the interval and the ratio are being clubbed together while we're defining on SPSS. So that is a brief introductory and making a sensitization to how we are going to, what things we are going to do on SPSS. Now let's move to SPSS and see how we can determine these missing number, how we can rectify those missing number, and then outliers, and then normality, linearity, and multicollinearity. Right. So let me share my screen again, the SPSS with you. I hope you must be aware of the SPSS. This is a statistical tool which has been used for the data analysis. Just give me a few seconds. I will be sharing the complete screen with you. So is the screen is visible to you? Okay.
Visible, visible.
Yes, yes. So can you see the on the screen that is why this? Yeah. So this is SPSS with us, and uh, this is a statistical software which has been used for data analysis. And these are the various tabs through which you can do various different functions. So what are the major functions for us to begin with? To how to open first, how to manage our data files, how we can bring the data into the spaces from Excel or from the SCV file, which has been already been saved in our system. So let's begin with, so I'm showing you how the path. So either you can go through this new tab, or there's always a folder option over here. You can click on the folder option, and then there's a predefined path. So since I am going to take the data from SCV, if you have the data on Excel, which is stored somewhere, so what is the first task? Usually we struggle, some newcomers struggle in this stage. You need to close your Excel file. This is the prerequisite, because SPSS will take on the file data only if your Excel file is closed. So select here, the Excel is visible, select Excel. So the first is click on your Excel file. It will, a new tab will come up, which will ask you the sheet, because there could be possibility when we collect, we frame our Excel sheet of a questionnaire. We have multiple sheets. So you need to define from which sheet you have the data, or the data from which sheet you want to do the analysis. Select the specific sheet, click OK. So this is how the data will come. The data will reflect on your SPSS, where the first tab, the first value of your Excel file will consider as the title. So that will coming on the top. So always when you're creating your Excel file, make sure the first row is defining the title, whichever you want to keep, so that you can identify. Now there's another way, another look which you can go through as a variable, right? Variable view. Now in this variable view, we need to define the decimals, that how much decimal output you want. That is the first thing. So define the decimal. So minimum we usually keep it at least 2. So you can keep 4, 5 depending upon your requirement, your need. The second thing is, these SPSS file can also act as your question. That means in the label column, you can write your question. That means the first question, the data what you have is representing which question. So that question you can write. You can make a double click over here, and then you can write your question, like what is the nature, what is the your approach, or whatever the question you have. Second is, go with the value, define value. That means if you see in the data, see over here, in data set we have numbers 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So we can define that what these values indicate. Let's say 1 indicates strongly disagree. Simply add 2, maybe disagree, and 3 you can write neither agree nor disagree, right? Similarly, you can keep on adding 3, 4, you can write agree, and then 5 you can write strongly agree. So this is how you can define your values for each particular column or each particular cells. So if you can see, I'll just show you the again data view, and in the data view there's an option called labels. You can see over here labels, right? So you see what representation we have put in the variable view. It is representing. So data will be converted into your representation of the, in terms of what it signifies. So again, I can make it in terms of number. You can go back to variable views, and then you need to define the scale. Scale, just what we have talked about, that in which scale this particular observation has been collected, this data has been collected, whether they are nominal scale, like for the age, gender, and so forth, whether they are in ordinal, maybe or income or so forth, whether they are being collected in interval or ratio scale. So for that we can define scale. So that is how we can do, because since we are using an interval over here, so we are defining, writing it as a scale, right? So that is the basic data entry what we should do, and then we can do it for all the columns, and we can see whether it has been reflecting in my data set or not. Now since I have already made all these entries, so I will take that data set and I will create a new sheet for you. So once you make all the data entry, so this is how it is going to show on your SPSS file. Now, if you want to see in terms of values, you can just simply click on this A and 1 symbol. You can see on the top, A and 1. So it will show you either in terms of number or either in terms of the values, so that you can check and see. And see over here. Here the labels, we have added all the questions. So even if you miss out your Excel file in the future and you have this SPSS file with you, you can easily determine for what question the first response has been taken, what was the values for which in which, or what scale in which it has been collected, right? So what was the scale which has been used, right? That we can take it from the same file. Similarly, we need to define for the all the cells. Now let's quickly move to understanding and determining the missing number. So how we can determine the missing number in my data set? Now you can see this is so large, so big data. It is difficult to identify one or two value which is missing somewhere in between. So how we can do that and I determine? There's an option or a tab which is considered as analyze. Click on analyze, then descriptive statistics, and then the frequency. So I'm considering the first response, one question I'm taking at a time for the reference. Transfer it to the variable view, select and transfer from here. So it is like select any, whichever you want to identify. You can identify all together at a one time or one by one, depending upon your choices. So just to keep it simple, I'm going one by one. So transfer it, right? And then simply mark it as okay. Now, if you can see, an output file will automatically generate. Now, if you can see, it is indicating the statistics, indicate how many missing numbers are there. The two missing numbers are there in the first column. So that you can also see from the table below, or the statistical frequency table, that what are the total responses, frequency for each kind of response which is there, so that we can determine. Now, this is not just sufficient determining what is the total count, but what is also important is to how we can handle with those data, how we can determine the exact position of those missing numbers. So for that, you can go back to the sheet, click on transform, right? Compute, click on compute variables, transform compute variable, right over here, missing number without space. Then from the function group, there's again an option which is known as missing value. Click on missing value. There you can write function group missing value. Then nmiss, click on nmiss. Then without clicking anywhere else, there's a question mark which is there. That means for which cell or which column, for which variable I want to determine the missing number. So I'm selecting the first one, so it is automatically get selected, and then simply click OK. Now see, the task has been executed by the SPSS. Now I can see the outcome. Scroll your sheet on the end. So here showing missing number, or you can write any value which you want to write. So it will represent with 0 and 1. It will represent with 0 and 1. 0 means there's no data which is missing. 1 indicates there's a missing value. So you can check exactly in which row the data is being missed. So here you can see 1. That means in this particular row, the data is missing. So I can identify in which row data is being missed out, right? So simple way of identifying the row or the specific cell in which the data has been missing. Now, second is how we can replace this and with what technique. So for that purpose, we can again go to transform and then replace missing a value. Replace missing a value. Now, since I want to replace for the first question or the first variable, select the variable. Either you can make a double click or simply click on this, transfer it to the new variable. Now, if I can recall, few minutes back, we have discussed the different ways of managing the missing number, either through the mean, either through the nearby points, either through the median of the nearby points, or the linear interpolation, or the linear trended point. So whichever technique you want to consider for filling this missing value. So let's most common technique is the series mean. So I'm considering series mean and click on the OK. Now go back and see the new column which has been generated with the missing value. So this was the column, this was the row where the data was missing. And now by replacing the values, we got the new value for the missing cell. So that is how we can manage the missing data in our data set. I hope that makes the things simpler for you to how to handle with the missing number and how to deal with the missing values and transform, identify, and determine. I'm sure you're getting it. Now let's look forward to the outliers. So for that, we should go to analyze, then descriptive statistics, and then explore. Right? Now we need to define. Let's say again, I'm considering the first. Let's say I'm considering second one. Go to dependent, transfer it. Go to plots. You can also check normality from here, but we are not going to check normality right now. So continue and OK. So here you can see there's no majority of data which is considered as outlier. Now we can similarly check for the other data, because it is not necessary that always there will be the outlier which is present in our data set. So again, go back to analyze, descriptive, explore, then click on outliers. OK. Now so it is still processing. So if you have any outlier, it will represent over here. It will represent out of the box. It will show the some position. Since there is no outlier in this, so there is no representation of the value which is representing over outside the box. Either it will indicate the position of the cell where the outlier value is present. Now let's move forward to the normality and the linearity. So whether my data is normal, whether my data is linear or not, that we can check. So again, for that, we will use a different data set. So I'm using another data set for checking the normality, because in this particular data set, we should not have any missing value or the outliers. So this is the complete data set value. And now we are going to check normality and linearity. For that, go to analyze, click on regression, and then linear. Now, once the tab is open with us, define what is dependent and independent. So defining my dependent variable and defining my independent variable. Right? And then go to the plots. In the plots, we need to specify the Z residual on y-axis and Z PRED on x-axis. Also, we can click on histogram and normal probability plots, because these plots will show us the graph, the structure which is there. So click on continue and click on OK. Right now, the first thing in which we can check is the histogram curve, where these histogram curve we can see the structure of the curve, the graph. If you can see, the majority of data closer to the central, the mean values, but there's an even distribution on the both the tests, and the curve look like a normal bell shape. So we can say there is the presence of normality in the data. There's the presence of normality in the data. Then we can check the linearity. How we can check the linearity? By the curve. Now you can click on the curve. If you see, the majority of the data are closer to the trend line, are showing a specific path which is moving upside. So that represents a linear structure. So that means that shows that the specific data what we have is showing the linearity as well as the normality. So linearity can be seen with this regression standardized residual curve, and normality can be checked with the curve what it shows in the histogram, right? So that's where we can make a comment about the normality and the linearity. Now in the next stage, we can check the multicollinearity, whether my data is showing the behavior of multicollinearity. So go back to the sheet, go back to analyze. There's two ways of checking the multicollinearity. First way is go to correlate and then bivariate. Define the which variable you want to check, right? Which all independent variable you want to check. Transfer it to the variable, right? And then select OK. Now, here you can see the value of coefficient of correlation. So what is the value of coefficient of correlation here is 0.693. Coefficient of correlation is 0.693, which means there's a positive correlation between these two variables, but not very strong collinearity. But there is some correlation between these two independent variables, which has been considered to check its impact on the dependent variable, right? The second way is of doing it is that, again, we can go to the data sheet, analyze. There's an option called regression, right? Then there's an option called linear. Click on the linear. So since here it is already predefined, I will do it for you. Define the dependent variable and define independent variable, depending upon whichever is being considered. Now, click on plots. So while clicking on the plot, we can see the statistics and we can click on collinearity diagnostic. So you can see on the screen in the statistics tab, there's a collinearity diagnostic. Click and mark it OK and then OK. Now, if you can recall, we talked about three fundamentals in which we can check the multicollinearity. The first and the foremost is the tolerance level, right? And the VIF value. So what is the tolerance value? So it is 1. So what is the tolerance value standard is? It should be less than 0.1, where the value is less than, his value is 1, which is more than 0.01. That means there's an absence of multicollinearity. That's not higher extent. Similarly, for a VIF, its value is 1, where VIF should be greater than 10. So that is how we can check the multicollinearity in our data set, which is the prerequisite, which is the basic assumption for the multivariate analysis, and with the help of tolerance and the VIF. So this is all how we can do the various and basic attributes identification, like missing number, outliers, then multicollinearity, normality, and linearity. So thank you so much. If we have any question, we can take on.
Yes, thank you, Dr. Sunil, for giving such an enlightening session. And you have spoken about so many important things, which is related to exploratory factor analysis. Of course, you have given the number. The data seems to be very complex, but I appreciate your efforts. You made it so easy and clear, which is, I think everybody who's participating in this workshop is able to understand. So, sir, I have some questions with me, which I have received from the participants, those who are still with us. The very first
Yes.
question I'm going to ask you is, with your permission, sir, how missing number and the outliers affect the data outcome? Because you have shown and you have spoken about the importance of these numbers and data, how it's going to affect.
See, when we talk about these missing numbers or the outliers, because that
Right.
making a direct impact on
Hmm.
the structure of the curve, it's making a direct influence on the standard deviation, the variation which is there in the data. So if my
Right.
data is being influenced, if my variance is being spread is more, then
Hmm.
there's a data which will be skewed. Then there's absence of the normality in my data. So that's makes a direct impact on the influence of the missing number and the outliers which is there.
Okay. Okay. Sir, my next question is, which I have received, is how outliers affect the normality of the outcome of the data.
See, again, it's again connected or what we talked about. We have seen how to manage with the outliers. We have seen a small set of information with us where we have seen the values. If majority of the data is like 10, 20, 30, 40, and 50, and so forth. But
Right.
suddenly there's a one value which is having like 500,
Hmm.
a 550. That might be arise due to the putting a wrong value, or that maybe arise due to the data entry, or maybe someone has intentionally given the wrong value. So that will again deviate the whole information or the outcome which we are going to get at the end. So that is how it is makes a very important impact.
Right. So one of the participants also sent me a question, that which is the best way to replace the missing numbers?
See, the best way I would suggest go with the series mean, the whole data
Mhm.
series mean, because that will again give a reflection of whole data set. So that is the
Right,
most appropriate for me.
right, right. So thank you so much, Dr. Sunil, for giving your precious time to us. Thank you so much. And with this, I just want to say to all the participants that not here, the workshop is going to end. No, we have the second session now, and the second session will be taken over by Dr. Monica Rose. So I welcome Dr. Monica Rose. She is with us. She'll join us very soon. And I just want to say that please enlighten us about the factor analysis, respectable academician, participating researcher, having presented best paper presentation in data. And apart from this, she has done MBA, MCA, and MSc in computer sciences. She possesses over 15 years of experience in corporate and academia, and has served in organizations of repute in India and overseas. Her contribution range from teaching, academic administration, consultancies, and research. She holds expertise in conducting research workshops, faculty development programs, and conclaves. Trained on business analytics from IBM Cognos, she is a passionate researcher, having presented and published research papers in reputed journals and premier institutions such as IITs and IIMs, and developed university-sponsored project also. She is a recipient of several scholastic performance awards, including Best Paper Presentation in National Conference and Best Paper Presentation in international conferences as well. So with this, I welcome Dr. Monica Rose. And Dr. Monica, without taking so much of time, I just want to say that please enlighten us about the factor analysis, and over to you, ma'am.
Thank you, Dr. Vandana, for such an elaborate introduction. Well, a very warm hello to everyone here. And well, continuing with our discussion, I hope you're all geared up with all your data, which has been by now, I assume, prepared to conduct factor analysis. So we have understood how different kind of data can be received while the data collection process is ongoing for our research projects. After handling the data only, we can conduct any kind of analysis. Today, we are going to discuss exploratory factor analysis. analysis. So let me share my screen and we'll begin with our discussion on EF. Can you see my screen?
Not now, ma'am. You just retry. Yes. Now it is visible.
Okay, so I would like to thank Dr. Sunil for such an elaborative discussion on data handling. So since our data is all ready to be worked upon, we continue our discussion with the analysis, but first we need to understand why we are using exploratory factor analysis. You know, when we are doing research, there can be n number of analysis that can be conducted, but why factor analysis? So here it's very important to understand that generally when we are conducting our research, as we have seen in our present uh, in the present questionnaire, there can be n number of questions. Assume there are 200 questions in our questionnaire. Analyzing those 200 questions and trying to make sense out of it is a very difficult task. Hence, in order to minimize that task, make our analysis simpler, we can reduce that data into smaller number of factors. So EFA, or exploratory factor analysis, is the technique that can help us in data reduction and also in identifying those independent factors which can explain all the behavior that we are trying to understand in our data through analysis. Now, for the discussion purposes today, we have taken a case scenario. Now, this scenario is about understanding the technology adoption of the students. Now, a survey was conducted. Now, this survey was conducted to understand whether the use of technology is helping the students in any way. And what we basically wanted to understand was whether the use of technology in the present context was use of Excel improve the information acquisition of the students, and also whether the use of Excel is helping the students improve their decision quality. Okay, so the survey was conducted with the university student, and the perceptions of their understanding on Excel making their life easier was, you can say, observed. We wanted to understand whether using this data, the answers can be sought on these questions. So as you can see in the present slide, this is a questionnaire, which had, you can say, mix of statement. So whenever we are, getting the survey, the questions can pertain to the analysis that we want to conduct, that is related to behavior, related to perception. The questions can also be related to items which may be personal, say for example age, gender, occupation, so and so forth. So basically there are two categories of question statement: one which are reflective in nature, another one which are formative in nature. Reflective are the one where we use a specific scale. Like in this case, we took all the reflective statements on a scale from strongly disagree to strongly agree. Those are the statements which are generally analyzed using any statistical tool. Here we are using EFA. So these kind of reflective statements, once the data is collected on them through the questionnaire items, we code them. We code them so that when we are, saving our result, generally the result is saved in Excel. So when we are saving those results, we identify those questionnaire items using some particular name. Like in this case, the names or the code names can be ID, A trust, C trust, and so on and so forth. And the scales can also be defined. So these are the basic things that are, done in order to prepare ourselves to conduct the analysis. And what we are trying to understand is information acquisition and decision quality. And there can be, a lot of relationship which may exist. We want to understand through our analysis how, in what ways, and what variables are, assimilating and relating to each other in order to bring out some important factors. Now, talking of factors, there are actually the analysis of factors in two categories. So one is exploratory factor analysis and second is confirmatory factor analysis. Exploratory factor analysis is basically, you have a priori theory, right? And based on that theory, you are just collecting the data and analyzing it. So that is a confirmatory factor analysis. Why? Because you already have the theory and you collect the data to confirm whether the theory holds good in that present context or not. However, EFA or exploratory factor analysis is generally conducted when the existence of a priori theory or any model or framework is not there, right? So you are conducting this particular exercise in order to understand, what can be the, you can say, underlying structure. So in this scenario, you are developing the hypothesis, right? You are actually validating the instruments, the you can say instruments which can be used to develop the scales. So EFA leads to development of hypothesis and CFA confirms or tests those hypothesis statements. So this is the basic difference between EFA and CFA. So EFA will help us, explore how many factors will be there which explain the entire behavior of our variables. CFA is basically concerned in whether the relationship as per the model that they have studied is the same in the present scenario or not. So EFA is associated with theory development and CFA is basically to check whether the loadings of the items is happening as it is expected or not. So, so in present scenario, we are making use of EFA, that is exploratory factor analysis. But when we use exploratory factor analysis, there are certain assumptions and few assumptions we have already discussed in the session taken by Dr. Sun. So our data must be normal. There should not be any multicollinearity. One very important assumption of EFA is that the data that we are using, that scale should be of metric nature. What do we mean by that? Metric means the scale item should be interval or ratio. If in previous sessions you have understood there are four types of scales: nominal, ordinal, Likert, and ratio. So if your scale is interval or ratio, then we can conduct exploratory factor analysis in that. Then second important assumption is that there has to be correlation, but this correlation should be within the variables, not between the factors. What do we mean by that? Now, we were just looking at the questionnaire, right? Now, if your questionnaire is having statement 1, 2, 3, 4, 5, 6, so and so forth, right? And those statements might be correlating with each other so that they indicate towards a certain factor. So what we are trying to establish here is those statements are having correlations with each other, and that is why they are indicating at certain factor. In other words, you can say correlation among variable exists. However, I must warn you here that there can be instance of multicollinearity also. Why? Because when we talk of different factors, the correlation between different factors should not be happening. Okay, I hope that you're not being confused in your mind right now. Let me just take an example here. Let us take a very simple example of say sales. Now sales can be influenced by maybe price of the product. Sales may be associated with the promotion of the product, isn't it? So here price is one factor. So your questionnaire items are the questions that you have put in your survey, in your questionnaire. So few of the statements on your questionnaire may indicate towards the price of the product. Okay, so that is one factor. Another factor is promotion, right? There should be correlation between price and statements towards price. That means EFA is good. However, if price is associating with promotion, those are two different factors, right? Then it creates multicollinearity, and it should not be happening if we want to conduct EFA, right? So there should not be any multicollinearity, and the sample size must be adequate. Sample size must be adequate. What do we mean by that? Generally what happens is when we take our questionnaire, we ask the respondents to fill it up, and we keep some number in our mind how many questionnaires we need to get filled. So there is assumption, generally speaking, that if we take 100, that is a poor number. If we take 300, that is a uh, very good or good number. Towards 400, 500, it is very good and excellent number. So this is a tentative indication towards sample size of data that we are collecting to run a good EFA technique. Hence, these are few assumptions apart from data being linear, and data should not be having any kind of outlier for the EFA to run. So I hope we are clear with these assumptions. So what is EFA, or exploratory factor analysis? It is that statistical approach which helps in determining the correlation in the variables. And this analysis, it helps in developing the structure of the factor based on those correlations, right? So you can say through EFA, you can make use of further advanced technique in order to conduct structured equation modeling. Okay, now I have been talking about statements on your questionnaire, right? And how variables are correlating and how factor is being formed, right? So I have just tried to give few minutes to this discussion to eliminate it further. Generally what happens is we say that any behavior that is caused, which we see through the data analysis, is caused through a latent variable that is known as factor or a construct. Okay, so factor or construct is causing the behavior, and the symptoms are the ones which we capture through the questionnaire items in our you can say survey item. What do we mean by that? Now, if say for example, you run a survey, okay, and on your survey, you try to collect the multiplication test score, division test score, addition test score of the students or any participants who are there. Now, through these values, assume that these scores are high. Okay, so if any participant is having high test score in multiplication, in division, as well as in addition, we would say that there is a latent construct or a factor because of which this kind of behavior is visible. Okay, there is a underlying factor because of which this behavior is caused. Now, this underlying factor, which we call here as math ability, is the factor we are talking about in the EFA or exploratory factor analysis, which we tend to identify. And these variables, addition test score, division test score, multiplication test score, are those statements on the on your questionnaire, on which you get the data collected from the respondents on Likert scale, on open-ended questions, and likewise. So these variables are known as observed variables, and this variable is known as latent construct or factor. So math ability, if the student's math ability, if the participant's math ability is high, obviously it is causing his multiplication test score to be high, division test score to be high, and addition test score to be high. So this is the phenomena behind the working of factor analysis. There are certain terms which you often come across when you run the factor analysis, which are commonalities, eigenvalues. So let us take them one by one. Commonalities are, you can say, estimate of variance which each variable is causing. So any value of commonality will tell us how much variance is caused in the variable due to the factor. And you'll come across eigenvalues also. Eigenvalues are some of those variances of the factor values. And you will also come across total variance explained. This is expressed by eigenvalue divided by number of variables. Factor loading, which is coefficient of correlation between variable and factor score, which is the score shown through the regression method in order to show how much factor is being observed. Now let's come to the action and conduct our factor analysis. I'll share my screen with you on which we'll see the SPSS dataset. Okay, so give me a moment. I'll unshare and reshare again. Okay, can you see my screen? Is the SPSS data screen visible?
Yes, ma'am. Yes, we can see.
All right. So now on the screen, you can see there are a lot of menu options. In order to conduct our factor analysis, we will go to analyze. In analyze, there is an option called dimension reduction. Remember, we talked about factor analysis is used for dimension reduction. Okay, so dimension reduction is the option that we'll choose, and in here the first option is factor. So please choose that option, factor. Now here you can see statements. These are those statements on our questionnaire on which we have collected our data. Now again, these question statements are in two categories. Okay, in your you can say by the perspective of understanding. So there are two categories. One is formative, second is reflective. Okay, so analysis will be conducted on the reflective statements. So what do we mean by that? All the data on which we have collected the perceptions of behavior of the participants, we will select those and take them in the variables. Okay, so we'll select from the first statement. You can see some statements are left here. These statements like gender, age, education are the values which are basically collected for understanding of our respondents or participants. These do not play any important role in the analysis of data. Hence, we categorize them as formatted statements, right? And all those which were reflective, we have taken in the variables section. Okay. And please make sure that these statements which are reflective must be on Likert or ratio scale. So once we have identified our variables, we will choose our options carefully. The first option that we need to see is in descriptives. In descriptives, we will choose KMO values. Now, what do we mean by KMO values and Bartley test of sphericity? Generally, when we are doing, factor analysis, there is a minimum criteria which tells us whether or not our data is fit for running the factor analysis, right, or not. So if the value of KMO is more than 0.60 or it's towards 1, we'll say our data shows a good fit towards running the factor analysis. Likewise, the Bartley test of sphericity. This Bartley's test of sphericity is meant to tell us whether there is correlation in our data or not. You will see all these values when we will get our results. So first things first, that we will make our options chosen correctly. So in descriptives, we will choose KMO values. There are other options also which you can choose and see the results, but for factor analysis to be run, KMO value is a must to be done. So KMO and Bartley test tell us whether the data is adequate enough or not to conduct the factor analysis. Once we establish that, then we look at what kind of extraction technique we can use. Now, there are a lot of extraction techniques which can be used based on what is your objective. As you can see here, there is principal component, unweighted least square, generalized least square, maximum likelihood, principal axis factoring, alpha factoring, and image factoring. However, we need to establish, why we are doing factor analysis. Now, generally speaking, if we are doing, our research in order to understand what are the underlying factors which are causing a certain behavior, right, in a given phenomena that we want to understand, we make use of principal component. Why principal component? Because principal component shows the variance both in terms of the specific variance as well as error variance of the variable that we have chosen. Another very you can say often used technique is, or very often used technique is, principal excess factoring. However, principal excess factoring is generally used when we are conducting studies like in psychology or in OB, organization behavior or development. We intend to understand what are the common variance amongst various factors, and we want to establish our analysis based on that. So if that is our objective, then principal excess factoring is used. And maximum likelihood method is used, and this is often used when we are conducting our CFA to move forward to structured equation modeling. So mostly principal component is the method which is used in order to understand how many what is the limit of the variance, and variance of how many types is shown by our data. And when I say how many types, generally the variance is divided into two categories, that is shared variance and unique variance. And unique variance is also of two types, which is error variance and specific variance. So principal component analysis, it takes in account all those different categories of variances in our factor. However, principal excess factoring ignores them. Principal excess factoring, which is the method here, only takes the shared variance. Therefore, we choose principal component. In here, by default, correlation matrix and unrotated factor solution are there. We can see the result through scree plots, which will help us in identifying how many factors have emerged, and then looking at extraction method. Looking at extraction method, there are two ways how we can do the extraction. One is looking at the ein values. Ein values generally, when we look at the variable, okay, and when those variables show correlation to indicate at a factor. Now, if the ein value of a variable is more than 1, if the ein value of a variable is more than 1, that means it is not caused by the variable itself. That means there is some external influence which is causing this variance in our variable, and henceforth, generally, extraction by default uses values based on ein value greater than 1. We can also use fixed number of factors, but this is used when you already know how many factors will be there, either through your literature review that you have done, or maybe you have knowledge of the a priori theory and you can make a guesswork how many factors will come. But generally we make use of ein values. Okay, so by now what we have done, we have looked at descriptives and we have selected our KMO and Bartlett test of sphericity. Then in extraction, we have chosen principal component X as our method, and we have selected scree plot to understand how many factors will emerge, and we are going with the extraction which will show us ein values which are greater than 1. Continuing with that, we will also choose rotations. Now in rotations also there are various methods that you can use in rotation. However, there are two common categories. One is orthogonal rotation and second is Oblimin rotation. Orthogonal rotation is a kind of rotation we use when we want to see how the variables are, correlating with each other, how the variables are, placed side by side along each other. Generally, in this type of rotations, we tend to place our factors at a in a perpendicular position, or you can say at a 90-degree angle. And the reason for doing so is this rotation helps in bringing highest level of variances in our variable. So the data variable can be in any angular position. So if through the rotation we place them in right angles, it helps us get maximum amount of variance showed by them, and that is why orthogonal rotational techniques are used, which are Varimax, Quantimax, Equamax. Another technique which we can use for rotation is oblique. In oblique, generally we make use of techniques which show us how these factors are away from each other. So here we have two options: direct Oblimin and Promax. So we will, since we want to see how many factors are aligning with each other, what kind of correlations are there, and how maximum amount of variances can be shown through this correlation, we are making use of orthogonal technique and we'll choose Varimax. Okay, so we'll choose Varimax rotation method. Rotated solution comes by default and maximum number of iterations is 25. We can increase them to 75 as well. Okay, so till now we have chosen the descriptive, in which we have taken KMO values. In extraction, we have chosen principal component, we have chosen our scree plot, and by default we are taking extraction which is based on the ein values. And in rotation, we are choosing Varimax. Now, if outcome of this analysis, you want to conduct another analysis from these scores, you want to run ANOVA, you want to run further techniques, then we take factor scores. If there is no further analysis that we want to do, then we do not require the factor scores. So in here, we will not take the factor scores. We'll go to options. Okay. Now in options, by default, SPSS helps you in addressing missing values. Remember, you had discussed the missing values and how to fix the missing values in the previous session. SPSS also gives you this option. However, it is suggested not to take from here because it is done in a very peculiar manner, right? There are three methods that are used in here. One is exclude case wise, exclude cases list wise. In this, the entire list of the responses is excluded when the analysis is being done. If you choose exclude case pairwise, so in here, say for example, there is a respondent number 6, and this respondent number 6 has answered almost all the questions except for few, right? So in this scenario, the cases are excluded pairwise. Then third option is there where we can replace with mean. But replacing with mean not always solves our problem. Why? Because sometimes the value may not be truly represented by mean as well. So we will go by the default option in here, as we have already sorted the you can say situation of missing values. Then the second option in here is coefficient display format. This helps us in making our presentation of factor analysis looks good. Okay, why? Because generally when we look at the output, the analysis, all the values, all the factor scores are shown. But if we want them to be visible in a sorted form, sorted by size, then we choose this option. And second is all the factor loadings will be available. However, we generally ignore the values which are less, so that only the significant values can be visible, because we do not require the smaller values. So we suppress the smaller values by value 0.40. Okay, and continue. So in descriptives, we have chosen KMO. In extraction, we have chosen principal component, scree plot, and eigenvalues. Rotation, we are going with Varimax rotation. And in options, we have sorted by size and we are suppressing values which are less than 0.40. And let's look at our output now. You say, okay. And I maximize my output screen. So this is how our output screen looks like. In our output, the first value that we will see would be our KMO and Barley's test. KMO and Barley's test. So for any factor analysis to run, for the data set to data set to establish whether or not this particular data is good to run factor analysis, the value of KMO should be higher than 0.60. Okay, so in here, if I look at my KMO value, that is Kaiser-Meyer-Olkin measure of sample adequacy, is 0.932. That is, it is towards 1. Okay, so that means it is a good measure. It is a good measure of what? Good measure that our sample is adequate. Our sample is adequate. Our sample is adequate enough that the factor analysis can be successfully run over it. Second value that we check in here is the Barley's test of sphericity. So Barley's test of sphericity generally help us in establishing. See, when we are running the factor analysis, we are trying to test the correlations. How many correlations are there based on which the factors will be identified. Okay, so we give a null hypothesis and we say that there are no correlation whatsoever in our data set. Okay, so our null hypothesis is that there are no correlation, right? So if our value of significance, that is p value, is less than 0.05, if the significance value is less than 0.05, we reject null. When we say we reject null, that means we reject that there are no correlations. So in here you can see significance value is 0.000. That is less than 0.05, right? that means we will reject our null. So if we are rejecting our null, that means there are correlations in our sample. Okay, that means it is a good indicator of factor analysis to be run. So this is, you can say minimum adequate requirement for the factor analysis to be run. Next important thing that we see here is communalities. Okay, let me share my screen again. I guess the output screen is not visible. I hope you can see the output screen now. Right. So this is KMO and Barley's test that we were talking about. So KMO value is 0.932. That means the sampling adequacy requirement is met. Higher the value, that means more the value is towards 1. That means our sample is adequate to run the factor analysis. And then significance value. Significance value in here is 0.000. That means it is less than 0.05. So that means we will reject null. That means our sample is having sufficient correlations for the factor analysis to be run. So KMO and Barley's test requirement is met, and henceforth we can continue with our factor analysis. Okay. So the second thing that we need to understand in our factor analysis is communalities. Communalities. Okay. So communalities, what is communality? I can see for the statement, I am spontaneous when I interact with XN is having a value 0.520. Likewise, I am imaginative when I interact with XL is having value 0.770. So these basically are the amount of variance that a particular variable. So this is one variable, this is another variable, this is another variable. Or you can say this is one measurement item, this is another measurement item, so on and so forth. Okay. So every variable will show a variance which is caused by the underlying factor. So how much of variance is explained by this variable because of the factor? So in this particular variable, the variance that is explained is 0.520. In this particular measurement item, the variance explained is 0.770. And through the entire, we can say I'm playful when I interact with XN. Here, the variance is 0.665. So we look at values which are higher than 0.40. Okay, so if the values of variance in here of communalities are greater than 0.40, then it shows a good indicator. That means the value are good enough to conduct the factor analysis. They show good amount of variance in our data set. Okay, so all the values, let us see if there is any value that is less than 0.40. So this is good, this one is good. Nice. Yeah, this is good also. Yeah, everything is greater than 0.40. In fact, there are good values, they are higher than 0.60 and 70. 8.807. 757,802. So these are good. So we need to make sure there is no value that is less than 0.40. So 0.757, 802, 818, 839, 789, 682, 619. Good. So for all the statements that you have in the questionnaire, which are reflective statements, these will be visible in our communalities table. And we must check the values of their scores. 0.802, 818, 839. These are good. These are also good. Okay, let's carry on. Let's see the remaining ones as well. 619, 620. Yeah, these are good. 645, 647. Very nice. So this is one value, 0.497. but it is also greater than 0.4. So we can go ahead with this. 750,645,647. This we have seen 0.497,589,69,693,732,5. These are good. Let's see the rest ones. 0.693, 0.732, 522, 609. So there is another value that is 0.450, but this is also greater than 0.40. So the values of commonalities are okay. Now imagine you come across a value whose commonality is less than 0.40. Then what do? In that case, we will eliminate that element from our factor analysis. I'll show you how to do that, okay? But here, since our, you can say, requirement is meeting, we need not take out any statement as yet. So we have seen the value of KMO, we have seen commonalities. Now we'll look at total variance explained. So while you're reporting, when you're writing in your thesis or in your research paper, what you are going to report, you will write the value of KMO was greater than 0.60. The value was 0.932. That showed that the sample had good adequacy, and the Bartlett test of sphericity showed the significance less than 0.05. That means the data set was good to conduct the factor analysis. And in commonalities, you will state that the value of all commonality scores were greater than 0.40. So the variance showed by the variable was good enough. Then we look at third table, that is total variance explained. Now, generally what happens is when we are running factor analysis, okay, for all the items that you have, for all the measurement items, or you can say questionnaire statements that you have, they will show their, extractions. Okay, so we had 43 statements, so all those would be shown. But since when we chose our method, we chose to show only those values whose eigenvalues are greater than 1. Okay, so the extraction will be shown for the factors where value of eigenvalue is greater than 1. So how many factors are actually having eigenvalues more than 1? Let us see. 1, 2, 3, 4, 5, 6, 7. So there are 7 factors who have eigenvalues greater than 1. And remember what we talked about eigenvalues? When a variable is having an eigenvalue greater than 1, then it confirms that the variance that it shows is higher than what an individual variable could show. That means it confirms the existence of some latent construct or existence of an underlying factor. And factors are the ones that we are trying to identify in here. Okay, so there are total 7 factors which have emerged whose eigenvalues are greater than 1. Okay, this is exactly how you are going to report in your research paper or in your project or in your thesis. So there were 7 factors which emerged whose eigenvalues was greater than 1. Second thing that we have to check in here is the variance that is explained. Okay, so we'll see here how much is the total variance that is explained. So from these 7 factors, the total variance that is explained is 69%. The total variance explained is 69%. So these 7 factors are explaining 69% of variance in all the measurement items. Okay, so you will see this extraction, this table is showing extraction before rotation, and these are showing extraction after the rotation. So generally what happens is, when you run the factor analysis, the first factor that comes shows the highest amount of loading, right? So you can see the first factor, factor number 1, whose eigenvalue was 14.391. It showed total variance of 33.467. And gradually rest of the factors will show their variances. But this is not what we want. What we want to see is, we want to see maximum variance that every factor can show. Okay, Since we want to find out the maximum variances in those factors, we rotate those factors. And hence in this table, you will see the rotated, the factors which have come after the rotations. And in here, you will see that the variance is being distributed. Okay, the variance has gone from 33 to 12, 12, 11, 10, 9, 6, 6, and so on. And total variance, and that is how you are going to report, total variance explained by these 7 factors was 69.766. Okay, so okay, this is good to go. Till here, we are okay with our factor analysis. Then we'll look at scree plot. Scree plot is another way how we can see how many factors have emerged. In here, we are we are able to identify 7 factors have shown the iron values are greater than 1. Scree plot also help us in identifying how many factors have emerged from the factor analysis. Okay, so let us see. 1, 2, 3, 4, 5, 6, 7. So till here we can see that if we try to make a cross here, okay, so this is point of deflection. So if we make a point of deflection, the place where these 2 arrows meet, place of divergence, can be the place where we can see all the values which are higher. So if I try to run a line here, okay, from here till here, you will see almost there are 7 factors which are coming above the line. That is what scree plot helps us in identifying how many factors are there which are explaining the total variance in our entire data item. Okay, so this is what scree plot are for. Then we come to rotated component matrix. So this is how the output of the factor analysis looks like. It is just like you can say a waterfall. You can see just like water falling out of a waterfall, the factor loadings emerge across the various measurement items, and they load accordingly. So if you can see in here, for total number of factors that have emerged is 1, 2, 3, 4, 5, 6, and 7. And for 7 factors, the loadings are shown like this. So these values are known as factor loadings. Okay, so these values, these 7 values show higher amount of loading towards these statements. That means this is indicating at 1 factor. Likewise, if I look at the second variable, okay, so these are you can say 7 statements which are indicating at second factor. But in here we have to check validity of our data. How will we check the validity of our data? Let us see if our factor loadings are significant or not. Oops, can you see here? These loadings were good enough, but there is a cross loading. There is a cross loading. So for the statement, Excel helps me identify problems. It is loading to factor number 3 as well as to factor number 6. This is not good. Now this scenario indicates that there are validity concerns. For any analysis to run, your reliability and validity must be sound. It must be established. But if there are cross loadings, that means there are validity issues and we need to address them. We'll do that. But let's see if there are any other values with similar kind of pattern. So for this, there is 1 cross loading. Let us look at the next factor. These are good enough, no cross loadings. These are also good enough, no cross loadings. Oops, there is 1 more. We can see in here, in factor number 6, there is 1 cross loading. Okay, so there is loading with factor number 3. Again, this is indicating at validity issues. So what are we talking about? So when a component, when there is cross loading of a factor, that means we are looking at discriminant validity issues. We are looking at discriminant validity issues. And if there are any discriminant validity issues, we need to eliminate those items. Remember, we were talking about eliminating items if the value of commonalities was less than 0.40. Same thing will happen here. Okay, so let us do that. So what we will do in order to resolve this discriminant validity concern, I'll go to analyze once again. Okay, so I'll go to my analyze option. In analyze, I'll go to dimension reduction once again and choose factor. And I'll see which factors were showing cross loadings. Let us see which factors were showing cross loadings. This one, okay, this is one statement which was showing cross loading. This is Excel helps me identify problems. Okay, let's find out where the statement is. Excel helps me. Excel helps me identify problems. This one, this one, this one, this one, probably the next one. Okay, let's see this. Where it is this? This one. Excel helps me identify problems. I choose this statement and I take it out of my analysis. Okay, I chose the statement and I placed it out of my analysis and I run my analysis again. Okay, my KMO value is still intact. It is greater than 0.60. Barley test of significance is, it is less than 0.05. These commonalities, values of commonalities greater than 4.0, greater than, 0.40. Yes, they are all 0.40, greater than 0.40, good enough. Very, very nice. Variance. Variance is increased to 70%. Remember, our variance was 0.69 earlier. It is increased to 70% now. That is a good news. Now let's look at our metrics. Okay, so first factor is okay, second is okay, third is also good, fourth is fine, fifth is also fine. But we have still problems in our sixth factor. Okay, so we need to eliminate this factor also because there is again cross loading, or you can say issues of discriminant validity. So once again, we'll go to analysis, dimension reduction. Okay, and we'll choose the statement. What's the statement in here? Excel helps me become more aware of information. Excel helps me become more aware of me. So let us find out where the statement is. Excel helps me become more aware of our information. This one helps me become more aware. Here. So this is the statement. We'll choose this and we'll take it out of our analysis. Okay. And you say, okay. And you run the analysis again. Right. Now, again, we'll check our KMO values. The value is still good, 0.930. So the model is good enough. Sampling adequacy requirement is met. Bartlett test is less than 0.05. So value is good enough. Commonality score less than 0.40. Yeah. All is well, very nice. So our statement are going good. We look at the variance explained, 70%, very well explained. This is meeting the requirement, and let's look at our component. So for first factor is good, second is good, third is good, no cross loading, fourth is good, fifth is good, sixth and seventh, all factors have emerged as good factors. So discriminant validity is met. And second, we look at convergent validity. That means value are greater than 0.50. So all the values here are greater than 0.50. 0.50 and 0.60 both are good enough. So we can see convergent validity requirement are also met in here. Okay, so this is all about our factor analysis. And using these values, we can report our findings and we can say that the factor analysis has reported 7 factors which have emerged, and we report the KMO values. We also report how much of variance is explained by those factors which have emerged, and we show the factor loadings through this diagram. And this diagram generally is pasted in our research paper or in our thesis to show the real analysis or real output of our data analysis. So this is how we successfully run our factor analysis. Thank you so much for being so patient throughout this analysis. I hope that it was all clear to you and you were able to make some sense out of it. Any questions, please?
Of course, ma'am, there's no doubt about it. You made it so easy for everybody. I mean, data, numbers, and analysis. Of course, it is a complex process, but hats off to you and to Sunil sir also. You made it so easy for others to understand. Well, ma'am, I have some questions from the participants and I want you to answer. The first question which comes to me is, how many variables are needed for factor analysis?
Oh, that's very good question. Generally, what happens is when we are, if you can look at my output screen also. So for the first factor, you can see there are some, good 7 statements. So if these statements are less than 3, then it becomes a weak case. So they shouldn't be less than 3. They shouldn't be 1 or 2 statements, because then we will not become, in a confidently we can say that our factor scores are good enough representative of the data. So they should be greater than 3.
Of course, ma'am, another question which is being asked by the participant is, what is a good sample size for, factor analysis? Because sample size is what is, matter of concern for everybody.
Yeah. Well, see, there are many theories and a lot of researchers have given different opinion on that. But we generally go with how many statements we have in our questionnaire. So say, for example, if I had 20 questions, 20 statements in our questionnaire, then we will go with, for every statement, we should have at least 20 respondents who are answering. So for 20 statements, it should be 400 is a good sample size, which will show us good analysis.
To have all the aspect of, research and all. Okay, okay. Ma'am, the other question is, can factor scores be negative? Is it possibility for them?
See, this is interesting. Just sometimes it does happen. If you again look at the matrix, the factor loadings, all the values are positive here. Right. But if you are running your analysis and apparently any other value comes negative, there can be one reason can be that your statement that you have coded is reverse coded. Say, for example, you are saying Excel helps me in analysis, Excel helps me in decision making in a more convenient manner. And there is one statement that you say, I disagree that Excel helps me in conducting my analysis. Right. So that is a reverse coded statement, and that is why the value are coming negative. For that, you need to reverse the values that are given. So if there are 17 statements, you will give a value, you will compute score by doing minus 18. So that is plus 1. Okay. So, there is some experimentation that our participants must do in order to see.
Yes, yes. Yeah. Ma'am, what is the use of KMO in this whole process?
KMO is the place where we begin our factor analysis. So if my value of KMO is not greater than 0.60, then my sample is not adequate only to conduct factor analysis.
Okay, so this is how it is also important to see the value.
Yeah, you can say this is the sufficient and necessary ground to conduct the factor analysis.
Right, right. One of the participants has sent a question: what is the basic difference between EFA and PCA?
Generally, when we say EFA or factor analysis, we are talking about principal excess factoring. So when we were talking about various methods how we can conduct factor analysis, right? So the methods were principal component analysis, principal excess factoring, maximum likelihood method, and so on and so forth. So when I say I'm running, factor analysis, I'm saying I'm using excess factoring method. However, if I'm using principal component analysis, I say I'm running factor analysis using PCA. So this is the difference.
Right, right. So with this, thank you so much, ma'am. Thank you so much for giving your precious time for the kind of information you have shared with us. And I think everybody, including Dr. Sunil, also I'm saying thanks to you, sir. We are running pressed against time, so we don't have much of time. I mean, everybody is thankful for this wonderful session where you people have enlightened us about something which is very complex in nature, which is hard to get. I think you made it easy and superb also. Thank you so much. With this, I extend my gratitude towards the MET Online University Chairman, Honorable Mr. Ajit Chauhan, sir. I just want to thank Professor Abhinash, who is Director of ADDOE and MET Online University. I extend my gratitude towards the IT team also, who has helped a lot to organize and conduct this kind of program, which is just next to impossible without them. So just thanks to everyone, to my entire team, my regards to the entire team who have indeed put in their efforts to the best of their capabilities to achieve a fruitful and successful event. Thank you. Thank you, everyone. Thank you, participants and everyone who have participated. Really very thankful.